Okay, calculus, let's do some word problems. Applications of Extrema usually include optimization, your favorite, building fences around things, finding max volumes, profit maximization, maximizing, minimizing, basically everything. We can now do the problems with multiple variables. A rectangular box is resting on the xy plane with one vertex at the origin. The opposite vertex lies in the plane 6x plus 4y plus 3z equals 24. Find the location of the vertex along this little triangulation such that you're maximizing the volume of the box. So what do we know about volume? It's length times width times height, or in our case, x, y, z. Okay, so what do we get? We know that if we're in this vertex, x has to be between 0 and looks like 4. Y has to be between 0 and 6, just by plugging in, because x, y, and z all are going to have to be positive, and z is going to be between 0 and 8. So let's solve this for z. We get 3z equals negative 6x minus 4y minus or plus 24. Which means z equals, dividing by 3, negative 2x minus 4/3 y plus 8. Okay, so that's my solution for z. How can I use that? Well, I want to plug this in here so that my volume is only in two variables. So volume is equal to x times y times that, negative 2x minus 4/3 y plus 8, which means my volume is negative 2x squared y minus 4/3 xy squared plus 8xy. So let's find the partials for volume. It would be negative 4xy minus 4/3 y squared plus 8y. Partial for y, negative 2x squared minus 8/3 xy plus 8x. Now when is this thing equal to 0? Okay, so we've got, I'm going to reorganize this for a second. One thing about this is we can factor out a y. So negative 4x minus 4/3 y plus 8. So either y is equal to 0, which of course if y is equal to 0, we don't have a box. So that's probably not going to be a maximum. Our other option is negative 4x plus 8 minus 4/3 y equals 0. Means 4/3 y equals negative 4x plus 8. Means y equals negative 3x plus 6. Okay, so if y equals negative 3x plus 6, I should be able to sub that in for the other one when I get there. So if one is fy equal to 0, I can factor out an x. Negative 2x minus 8/3 y plus 8. I take that negative 3x plus 6. Either x is 0 or negative 2x minus 8/3 y plus 8 equals 0. If we put in negative 3x plus 6 here, negative 2x minus 8/3 times negative 3x plus 6 plus 8, 0. We're now substituting. Fun times. Sorry if it was off the screen. Let's put it back on the screen. What happens when I multiply this by 8/3? Negative 2x. 3's cancel, negatives cancel, looks like plus 8x. Negative 8/3 of 6 should be minus 16 plus 8 equals 0. So looks like 6x minus 8 equals 0, so that means x is 8/6, or 4/3. Now if x is 4/3, I can get y. 3's cancel. Negative 4 plus 6 leaves y at 2. I don't have to worry so much about this. So what is this going to mean for z? Well, we'll get back there in a second. So we know that our only real points are at 4/3, 2. We could test when x can be 0 or when y can be 0, but it makes no sense from a volume maximizing perspective that we would test anything with a dimension of 0. That's not going to maximize your volume. So let's test our second derivatives with respect to each of these. F of xx is, there's only y's left here, so these are gone, so it'll be negative 4y. F of y equals negative 8/3 x. F of xy, however, equals, let's take this derivative with respect to y, that's negative 4x minus 8/3 y plus 8. Okay, so at the point 4/3, 2, let's see what happens. So if you plug it in at 4/3, 2 for x and y, and then there's a point for z as well. This would be negative 8. This one would be negative 32/9. Yeah, negative 32/9. What is this thing? So these two multiplied together will be 256/9. F of xy becomes plus 8 here, but this is negative 4 times x is negative 16/3. Negative 8/3 times y is negative 16/3 plus 8. 8 minus 32/3 is negative 8/3. We need to square that. So we get 256/9 minus 64/9, which is greater than 0. So if d is greater than 0 and f of xx is negative, we have a maximum. So these dimensions maximize. Let's go find the z that goes with it. So we have 4/3, 2. We know z is negative 2 times our 4/3, so negative 8/3 minus 8/3, negative 16/3 plus 8. That's 24/3 minus 16/3 should be 8/3. 4/3, 2, 8/3. Ironically, that's 4/3, 6/3, and 8/3. Because these were all linear, it made more sense to split them all evenly based on their ratios of where they could be in the triangle. If we multiply them all together, the actual volume of these three things multiplied together should be 64/9. And we'll skip number 2 and we'll do number 3 in the video.